Hey there, this is Kale, product engineer here at Inworld, and today we are going to be building a language learning app together while learning how to use the Inworld runtime. So this app is going to have two components. One is a conversation where a user is going to be able to speak with a Spanish-speaking AI tutor and have a natural conversation with them. And the second component is a flashcard system where during the conversation, depending on what you're talking about, flashcards about that topic will be generated so you can use them later for studying. As you can see from my to-dos section, I have started, so I'm not going to make you watch me code up this front end. Our focus is learning how to use the Inworld runtime, which is a graph running system enabling you to run AI apps at scale. We're going to be building together and learning a few of the features and best practices to make these apps. So we've done voice activity detection and speech to text so far. Voice activity detection is actually not part of our graph. It's part of our app logic, and it determines when to run our conversation graph. So when we detect, or more accurately, when the Celero model, it's a voice activity detection model that we're actually running on device through the Inworld runtime. When it detects speech, that's when we're going to call our graph, which we need to start building together. So what we're going to do is first we will create our first node. So graphs are composed of nodes. We now have our first node. Next, we need to create our graph executor, and we'll call it the conversation graph, same as our file name. The less tricky things to remember, the better. And now let's start adding well, in this case, our graph only has one node, so we're going to add it. And then we're going to set our start node and end nodes. And we are going to build our graph. And this function, this function, create conversation graph, will return the executor. Very simple. We'll be expanding this to encompass our entire use case. What happens next, now that we've returned the executor from this function, is in our audio processor. This is what's processing all the audio the front end is sending, checking it with our voice activity detection model on the server. And when it's time, we are executing our graph. This is the executor from the previous function. A graph can return one thing or many things. Usually it's many things, kind of a chunk of output, which can be text, which can be audio, etc. And so now we are using our process response function to safely process the output. If it's a string, which our transcription is going to be, because our speech to text node takes in audio as input and outputs text, the transcription. So that's what our, because it's the start node and end node of our graph, the graph itself is taking in audio and returning text. And we get that text, it's the data, so we're going to set it to a variable in this audio processor. Then we're going to send it to the front end, and then we're going to just keep a little bit of state tracking what was said and when it was said. So let's now see if our app will run. Hola, ¿cómo estás? Hey, brilliant. So our graph has, okay, so it can stop executing. We see our graph ran. We spoke for a second and a half, and we got our text. So that is pretty cool. In the next video, we're going to put together the rest of our conversation so we can have an end-to-end chat with our AI teacher. So stick around. I'll see you in the next video.